So to find where the function is concave up, concave down, and the points of inflection, we need to look at the second derivative. So that's the first thing we're going to start with. To get to the second derivative, we need to start with the first derivative, which is going to be 3x squared minus 12x minus 2. Second derivative is going to be 6x minus 12. Now the process for concave up, concave down is the same as the process for increasing and decreasing with the first derivative test. So we're going to take our second derivative, set it equal to 0, and solve for x. So what we know here is that when x equals 2, our second derivative equals 0. So this is, like I said before, exactly the same process as with the first derivative test. So we'll take our number line. We know that at 2, our second derivative, which is 6x minus 12, is 0. And now we need to see what the value of that derivative, of that second derivative is on either side of 2. So I'm going to pick 0 and 3. So I'm going to go and find f double prime of 0. Which is negative 12. So to the left of 2, second derivative is negative. Same process on the right of 2. We get 6, which is a positive. So to the right of 2, second derivative is positive. What positive and negative tell us here is what the concavity of the function is, whether it's concave up or concave down. Now, concavity, it's just like hills and valleys. Concave up, have a valley. Concave down, we have a hill. So this function is concave up when the second derivative is positive, so from 2 to infinity. Function is concave down when the second derivative is negative, so from negative infinity to 2. Point of inflection happens when we have a sign change in the derivative and we have a 0. Okay, if you remember back to the first derivative test when we had rational functions, sometimes we had an infinity on our sign analysis. If we have an infinity with the second derivative test, that is not a point of inflection. So here we have negative to 0 to positive at 2. That is going to give us a point of inflection. The coordinates of that point of inflection will be 2 comma something. To find out what the something is, we need to go back to our original function and find what f of 2 is. Work that out. So that point of inflection is at 2 comma negative 16.